I just got a support ticket that made my blood run cold. A user named Sarah opened her chat and saw messages from someone named Mike. Messages about his rental, his credit card, his location.
Let me guess. You thought it was a one-off bug?
I checked the logs. It wasn't one user. It was 12 users, all seeing each other's messages. Private conversations, payment details, addresses, all mixed together like some kind of data nightmare.
WebSocket connection pooling gone wrong. We had the exact same bug in week 3, and it gets worse.
How does it get worse than users seeing each other's private chats?
Because by the time we caught it, the messages had already been stored in the database, mixed up. User A's message was saved under user B's chat history. We had to write a migration script to untangle 4,700 messages.
Oh my God. How did this even happen? I thought I just had to open a WebSocket connection.
That's what everyone thinks. You call Socket Connect, messages start flowing, everything looks fine. But here's what you didn't account for. Connection drops.
Connection drops?
User switches from Wi-Fi to cellular. User goes through a tunnel. App backgrounds for 30 seconds. Every time, the WebSocket connection dies. And when it reconnects, if you don't handle it properly, you get duplicate connections, messages out of order, or worse, messages routed to the wrong user.
So I need to handle reconnection logic, like detect when the connection drops and reconnect automatically.
Yes, and not just reconnect. You need to authenticate again. You need to resubscribe to the correct channels. You need to check for missed messages while you were disconnected. It's not one line of code, it's an entire state machine.
State machine?
Your WebSocket can be in 5 states: disconnected, connecting, connected, reconnecting, or failed. Each state has different rules. When you're connecting, you queue outgoing messages. When you're connected, you flush the queue. When you reconnect, you fetch missed messages. If you don't track this, chaos.
So that's how messages got mixed up. The connection dropped, reconnected, but it reconnected to the wrong user's channel.
Exactly. We were using the user's device ID to identify connections. But device IDs aren't unique to a user. If 2 users logged in on the same device at different times, they'd share a connection ID. Disaster.
So how do you fix it?
Authentication tokens. Every WebSocket connection sends a JWT token. The server validates it, extracts the user ID, and ties that connection to that user. If the token expires, the connection gets dropped. No token, no chat.
Okay, so we authenticate. What about streaming AI responses? Episode 4 teased that. How do you get word-by-word responses like ChatGPT?
That's actually the coolest part. You use server-sent events or WebSocket streaming. The AI generates text in chunks, and each chunk gets sent immediately. On the client side, you append each chunk to the message in real time.
So instead of waiting for the full response, you show partial results?
Right. The user types, "Show me BMWs near Zurich." You send that to the AI. The AI starts generating. Sure. You display sure. Then, I found. You display sure, I found. Then, 3 BMWs. You display sure, I found 3 BMWs. It feels instant and alive.
That's so smooth. But how do you handle the UI? If the message is still being written, how do you scroll?
You use a scheduler reader in SwiftUI. Every time a new chunk arrives, you update the message content, and SwiftUI automatically triggers on change. You detect that change and scroll to the bottom. The user sees the AI typing in real time.
And typing indicators, like the 3 dots.
Typing indicators are hilariously simple. It's just an animated view that shows when is-a typing is true. You set is-a typing to true when you send the message, false when the response finishes. 3 lines of code for something that feels so polished.
Okay, so we have authentication, we have streaming, we have typing indicators. What about offline support? If the user has no internet, do messages just vanish?
No, you queue them locally. When the user taps send, you add the message to a local array immediately. Then, you try to send it over WebSocket. If it fails, you mark it as pending. When the connection comes back, you retry. The user never sees the failure. They just see sending, until it succeeds.
What if they close the app before it sends?
You persist the queue to used data or core data. When they reopen the app, you load the pending messages and retry. This is critical for a good user experience. Nobody wants to lose their messages.
All right, let's test this. I've implemented everything. Let me run the app.
Open the chat, send a message, watch the logs.
Okay, typing, find me a Tesla Model 3. Tapping send. The message appears instantly. And now? Oh, the typing indicator is showing. 3 animated dots.
Now, watch the AI response stream in.
Oh wow, it's coming word by word. Sure. Then, I found, 2 Tesla Model 3s available near you. This is so cool. It feels exactly like ChatGPT.
Check the console. What do you see?
WebSocket connected. Assigned as user_123. Message sent. Streaming response chunk 1. Chunk 2. Chunk 3. Response complete. Everything worked.
Now close the app and reopen it. Are the messages still there?
Closing. Reopening. Yes, the entire conversation is still here. It persisted.
That's because we're storing messages locally. Every time a message arrives, we save it to core data. When you reopen the app, we load the history. Instant. Offline first.
What about the other disaster? Messages appearing out of order.
We fixed that with timestamps and sorting. Every message has a server-side timestamp. When we load messages, we sort by that timestamp. Even if messages arrive out of order due to network delays, they get displayed in the correct sequence.
And duplicate messages. How do you prevent those?
Message IDs. Every message has a unique ID. When a new message arrives, we check if we already have a message with that ID. If yes, we ignore it. If no, we add it. Simple deduplication.
Okay, I feel so much better. We went from users seeing each other's private chats to smooth real-time streaming with offline support. That's a huge win.
And the best part? This pattern works for any real-time feature. Notifications, live updates, collaborative editing, same WebSocket infrastructure.
All right, so users can browse cars, they can chat with an AI, and they get real-time responses. What's next?
Booking. The single most complex feature in the entire app.
More complex than real-time WebSockets?
Way more complex. Calendar availability, partial day rentals, overlapping bookings, cancellations, refunds, time zone handling. We had a bug where users could double book the same car because 2 requests hit the server at the exact same millisecond.
Double booked the same car?
Yep. We had to introduce database-level locking, optimistic concurrency control, and a retry queue. And that's not even the worst part.
What's the worst part?
Payment processing. Stripe webhooks. Failed payments. Partial refunds. Users booking a car, paying for it, then immediately canceling and demanding a refund. We lost $1,200 in 1 week because our refund logic was broken.
$1,200?
Episode 6. The Booking Beast. And trust me, you're going to want to see how we fixed this.
I need to know. This sounds like a nightmare.
It was a nightmare, but we survived. And I'll show you exactly how to build a bulletproof booking system. Episode 6, coming up.